n equals to j, and then it'll look the same. If we do that, then the resulting sums will both look the same, right? So we have the sum j equals 0 to infinity. N is j plus 2. We have j plus 2, j plus 1, a sub j plus 2, x to the j, plus the sum j equals 0 to infinity of a sub j x to the j equal to 0. Well, this is wonderful. Now I can add them because they're both of the same format, right? So I can rewrite this as a single series. J equals 0 to infinity, big parentheses, j plus 2 times j plus 1, a sub j plus 2, plus a sub j, parentheses, x sub j, upper j rather, equals to 0. Now this identity has to be true for all x, right? The only way that can happen is if the thing in parentheses is 0 for each value of j. So this gives us a condition on the coefficients, the a sub j's. Right, so what do we find? So we've got basically, we can solve that for, say, a sub j plus 2. A sub j plus 2 is equal to what? Minus 1 over j plus 2 times j plus 1, right? Do you guys agree? Does that make sense? A sub j plus 2. This altogether has to be 0, right? So if that's the case, I can solve for a sub j plus 2, and I get minus this reciprocal over a sub j, right? Do you guys agree? And now what we do, this is a recurrence relation. See, it relates the j plus 2th one to the jth one. This is a recurrence relation. And the way to solve these is just to get down and dirty and just start plugging in some numbers and try to ascertain a pattern. So we're just going to start plugging in some numbers, like plug in 0, plug in 1, plug in 2, plug in 3, plug in 4. What happens? Let's start out with j equals to 0. What do we get for j equals to 0? We get a sub 2, right? Is what? Minus 1 over 2 times 1, a sub 0, right? It looks to me like there's going to be a connection between the even terms, right? So actually, rather than doing j equals 1 next, I'm going to do j equals 2 next, because I'm already starting to see a pattern. J equals to 2. What do we get there? I get a sub 4 equals to minus 1 over 4 times 3, right? A sub 2. But that's what? That's really minus 1 squared, 4 times 3 times 2, a sub naught. Yeah. What's the next one? J equals to 3, right? J equals 4, rather, sorry. J equals to 4. Let's see here, a sub 6. Looks like, I got minus 1 over 6 times 5, right? But plugging in that, a sub 4, right? Sorry. So plug that's my a sub 4, plug it in here. I get minus 1 cubed, right? 6 times 5 times, well, come on, it's 6 factorial, right? You see what happens with a sub 8? Do I need to write down a sub 8, or can you already see the pattern? What's a sub 8 going to be? Well, let's just jump. You can see a sub 2j is equal to what? Oh, maybe 2j is a bad letter. Let's say a sub 2k is equal to what? Looks to me like it's minus 1 to the k divided by 2k factorial, right? Because it sees the 6 and the 3, the 4 and the 2 and the, see the pattern with the minuses? So it's like this is 2k, but that's just k up there. And that's a sub 0, right? So we started with this infinity of coefficients, but these recursion relations, which derived from the differential equation, actually force us to just have the whole string of even ones just linked to the 0th coefficient. Likewise, what? Through a very similar calculation, you can derive that a sub 2k plus 1 is equal to minus 1 to the k divided by 2k plus 1 factorial times a sub 1, right? So just, I'll start it out. A sub 3 is minus 1 over 3 times 2, a sub 1. A sub 5 is minus 1 over 5 times 4, a sub 3, which is minus 1 squared over 5 factorial. A sub 7, minus 1 over 7 times 6, a sub 5, which is minus 1 cubed over 7 factorial, and so forth. All right, so put it all together. What do you got? Y is equal to a sub naught times the sum, k equals 0 to infinity, minus 1 to the k, divided by 2k factorial, x to the 2k, plus a sub 1, sum k equals 0 to infinity, minus 1 to the k, divided by 2k plus 1 factorial, x to the 2k plus 1. Of course, you know them, you love them, you recognize them. This is nothing more than your favorite cosine of x and your sine of x. And so we have, in a rather different way, derived this result, which I essentially guessed earlier in the course. I didn't guess it in this calculation we just did. I derived that as the solution to y prime prime plus y equal to 0 by working through what's forced upon us by calculus for a power series solution. This method of calculation is very general. All right? When we teach differential equations, I teach basically the stuff I showed you earlier in the course, plus extra things for other special examples. All right? And higher order stuff, and more things about non-homogeneous cases we haven't touched on. There's more, of course. I mean, this isn't the differential equations course. We're just getting started. I show you the easiest and most applicable examples in here. But past all that in differential equations, eventually, when the dust settles, we get to the power series solution technique. And that picks up the rest. Everything you can't do by elementary methods, you get by power series methods. And in fact, this even has generalization. Like, you can look at things beyond power series, so-called Frobenius series. And those are used to solve all the problems that have names like Bessel functions and other things, Airy functions, hypergeometric, all of these things. Basically, more or less, this same calculation. So I know you have an easier way to solve this problem already, but what I'm telling you is if you understand what I just showed you, you can solve a very wide class of problems. And it's part of the reason we like power series. I'm sure I forgot something, but that's pretty much it for power series. That's most of what I have to tell you. So tomorrow, of course, is assessment day. Thursday, I just have for your homework questions, whatever you got, right? And then Friday, I think Friday I probably should go on to the stuff that's not tested. I probably should spend Friday on chapter 10. Otherwise, we're like kind of short on class time for the fourth test. So I think I'm going to take Friday to do material past the test that won't be tested on the test, obviously, right? Rather than giving you a quiz and collecting it, I'm going to give you a quiz that I might have collected, let you work through it, and we'll talk about the solution to it instead. I think that's more productive because I don't see myself having time to grade another quiz. If I can just get the quizzes you guys given me already graded by Thursday, it'll be a win. Okay, so thanks, guys.